Hey guys, welcome to my channel, and today I'm recording Cambridge O Level 5070 paper 1. This is October-November 2020 and this is an MCQ based paper, variant 2. So without any further ado, let's get started. I have already solved its part 1. You can check it out. I'll put the playlist link in the description below, or you can click the eye icon over here and you'll be able to find it. So let's get started from MCQ number 11. MCQ number 11 says, which statement describes the ionic bonds? A lattice ions in a sea of electrons, electrostatic force attraction between oppositely charged ions. Well, of course, if you talk about ionic bond, let me zoom it in. It's not sea of electrons. That is basically metallic bond, where we have positive ions together and then we have sea of electrons around it. So it's of course not ionic bond. And electrostatic attraction between oppositely charged ions, yes, because we have positive and negative ions attraction that forms an ionic bond. MCQ number C says, option number C says, sharing of electrons between the atoms to gain a noble gas configuration. No, it's not sharing of electrons, that's covalent bond. And transfer of electrons from atoms of a non-metal to the atoms of a metal. Well, no, it's not true, because non-metals do not transfer, of course there's transfer of electrons, but over here, if we see over here, it's not from non-metal to metal, it's metal that loses electrons and non-metal that gains electrons. So here, this is wrong. This is why it's not option B. So make sure you clearly read every option so that you don't get confused. Because at times these little things we just do not notice and we look at transfer of electrons from metal to non-metal, and at times it gets really confusing, specifically when we are under the atmosphere of examination. So moving on to MCQ number 12, which substances contain at least one double bond? Okay, so if we look over here, the options given to us is C2H4, then we have O2, and then we have C2H6, we have CO2. Okay, so for this, we can say, if we look this, yes, this has at least one double bond. C2H4 has, because it's an alkene. Alright, an alkene, it's like this, okay, it's like carbon, and then we have double bond between them, and then we have 1, 2, 3, 4 hydrogens attached to it. I haven't written hydrogens, but you understand that hydrogens are over here. So it's, of course, C2H4 can be the right answer because it has a double bond. Then if we see oxygen, yes, it again has a double bond, correct. And C2H6, no, this does not have a double bond. I'll tell you how. This is C, then this is the other C. Okay, let's not draw the bond at the moment. Okay, and then we have, because it has 6 hydrogens, so 1, 2, 3, and then 1, 2, and 3 hydrogens. So these are 3 hydrogens being shared. Now carbon has the capacity to make 4 bonds or share 4 electrons. So since 3, each one of them are sharing, so only one bond is left. So this carbon will share a bond and this carbon will share a bond. So together, only one bond will be formed, right? Sorry, this carbon will share electrons and this one will share electrons. So together, they'll only share, single bond will be formed, right? One electron. So single bond will be formed, not double bond. So this cannot be the right answer. And then we have carbon dioxide. Yes, it has double bond. So yes, this can also be the answer. So it's going to be 1, 2, and 4. That is option C over here with us. Moving on to MCQ number 13, magnesium will react with aqueous copper 2 sulfate to form copper and aqueous magnesium sulfate. What is the correct equation for this reaction? Okay, so if we look over here, magnesium is reacting with aqueous copper 2 sulfate, that is CuSO4, and then to form copper and aqueous magnesium sulfate. So, and they form copper and they have magnesium sulfate with it. So if we look over here, we need to have a balanced equation firstly. So Mg, right, Mg is for magnesium, we'll have Mg plus, we'll have CuSO4. So these both have, all of these have this, but not this one, right? So this is Wrong, this cannot be the right answer because it's the formula for copper sulfate is not Cu2SO4, it's CuSO4, since both of them have, like, this is Cu is 2 plus and SO4 is 2 minus, so together they have CuSO4. So it can either be A or C. Let's see. Ahead, to form copper aqueous magnesium, copper, this is copper with us. We also have copper over here, so, and we also have magnesium sulfate. Magnesium sulfate is MgSO4. It's not Mg2SO4 because again magnesium has 2 plus charge and sulfate has 2 negative charge, so together they have MgSO4. So C cannot be the right answer and A is the right answer. So now moving on to option number, MCQ number 14. A sample of magnesium hydroxide has a mass of 4.63 grams. How many moles of magnesium hydroxide are present? If we look over here, we have magnesium hydroxide, which is, we will use the formula of N is equals to mass upon MR. So basically this is the mass and we have the MR, and how are we going to do it? Mass is already given to us, we can find out the MR easily looking into the periodic table. If you look at the periodic table, so magnesium is 24 and hydroxide, let me write the formula for it. Magnesium and hydroxide. Now since magnesium has a charge of 2 plus and hydroxide is minus only, so it's going to be MgOH2, right? MgOH2, because to fulfill it, we're supposed to have 2 hydroxide ions with magnesium. So now if we look over here, Mg is 24, 24 plus 16 plus 1 and 16 plus 1 will be multiplied by 2, that is 17 multiplied by 2 plus 24 is equals to probably 58 if we calculate it, and then 4.63 will be divided by 58 and we'll get the answer of moles. Now how has this formula come? It's very obvious over here that if we are supposed to find how many moles are over there, we are going to take the ratio of mass and MR. MR is basically, it's, you can say, molecular mass. It's very normal molecular mass according to periodic table, it's general mass. And if we want to see that how much molecules are there or how many moles are there of magnesium, so we can easily do it through finding through division. Okay, so this is how you can find out its answer. Its answer is 0.0798 if we divide 4.63 with 58. Let's move on to MCQ number 15. Which statement is correct? The concentration of a solution is expressed in dm cube per mole. If we look over here, no, it's not dm cube per mole. Concentration of solution is not measured in dm cube per mole. Then we'll look at part MCQ number, option number B. Empirical formula for compound always gives actual number of each type of atom in one molecule. Okay, so let's look into this. Here we have empirical formula for compound which gives actual numbers of each. No, it's not true, because empirical formula is the smallest formula of something, the most minimum formula that can be formed. The molecular formula for compound always contains one more atom than the empirical. Not importantly, sometimes it can have more. So no, it's not true. D, the relative atomic mass of an element is the average mass of an element 1/12 masses of carbon 12. Yes, this is true. This is true. Okay, so its answer is D. Moving on to MCQ number 16, which sample contains the most atoms. So it's basically 0.5 mole of water, 1 mole of carbon dioxide, 1 mole of methane, and 2 mole of hydrogen chloride. If we look into it, we'll easily be able to understand. We'll find the MR of it, and then we'll do with moles, and we can easily do it through using the Avogadro's number. So it's really simple question, very basic, from I believe chapter number 1 or 2. And for this, if we look, the answer is going to be C. Why do I have the eraser on? Okay, C, 1 mole of methane. Okay, so we'll do the calculation and we'll easily be able to find it. To make it short, I just directly wrote the answer since I calculated it before. So you can calculate it in examination and easily find it out. Moving on to MCQ number 17. The equation shows the production of iron by reduction of iron 3 oxide. 80 tons of iron 3 oxide produces 50 tons of iron. What is the percentage yield? Okay, so this is a very interesting question. We have 80 tons of iron 3 oxide. That means when this is 80 tons, it gives 50 tons of iron. First of all, you are going to look at the mass of it, that is calculate the mass. Okay, now how you're going to calculate the mass is by finding the mass of Fe2O3 and finding the mass of iron, and then after it you're going to multiply it with 80 and you're going to see that how much iron, and use the ratio method and find how much iron should be produced in normal conditions. That means once you find the mass for this, you find the calculated mass for each using this ratio of 1:2 moles. You'll find the mass and then you will multiply Fe2O3's mass with 80 tons of iron trioxide, and then you'll find the calculated mass of iron. Then after it you're going to put 50 tons of iron and divide it with the calculated mass, multiply it with 100, and you will get a percentage yield of, I believe if we calculate it, it's going to be 89%. Okay, I've already calculated before. Since you've seen many of my papers, I've calculated so many questions over there in the paper, and some of them I've done off paper, so I can reduce the chaos and easily complete it within a given time. Moving on to MCQ number 18. Aqueous copper 2 sulfate is electrolyzed using copper electrodes. The current is constant and the anode is weighed at regular time intervals. Which graph is obtained when mass of anode is plotted against time? Mass of anode, and this is time. Okay, so if you look over here, this cannot be the right graph, since mass of anode is not decreasing in this way. Alright, it's not increasing in this way. Again, mass of anode is not increasing, so it's not going to be this, and it cannot be this, both of them. The current is constant and the anode is weighed at regular time intervals. For this, the answer is going to be C, because the current here is constant and the mass of anode is gradually decreasing and along with time. So that's why it's going to be this. That's option number C. Moving on to MCQ number 19. The diagram shows electrolysis of a mixture of aqueous copper 2 nitrate CuNO3 and aqueous silver nitrate AgNO3. Electrodes X and Y are inert. Copper is above silver in the reactivity series. Since we already know reactivity series, so it's going to be hydrogen, copper, then we have silver, gold and all. So it can be deduced that 1 is initially a deposited electrode dash. Okay, 2, that is which statement is correct. If we look at this question, since silver is closer to the line of discharge, now what's the line of discharge? Line of discharge is basically the one which is lesser reactive, discharges more quickly. So silver is going to be, it can be deduced that over here silver is initially deposited, and at which electrode will it be deposited? We can easily tell that it will be deposited at electrode Y, that is the negative one, this one. Okay, electrode Y, because it is lesser reactive and more closer to the discharge. It's less reactive and more closer to the displacement line, line of discharge. So here the answer is going to be D. Moving on to MCQ number 20, the energy profile diagram of a chemical reaction is shown, reactants and products. What is the value of activation energy of the reaction? Okay, so what's the activation energy? Basically, activation energy for this is going to be C. Why? Because this is the activation energy. Alright, and activation energy will be 150 and between 150 and 250. So 250 minus 150 is going to give us plus 100 kilojoules per mole. So that is why this is going to be our answer over here. That is it for this video. I hope you found it helpful. Make sure to drop your queries in the comment section down below. I'm going to be uploading its part 3 and 4 really soon, so make sure to subscribe and ring the bell icon. And if you have any queries, so make sure to again drop it in the comment section down below. Check out my playlist in the description. And yeah, that's all for my video. Thank you so much for watching and best of luck for your exams.